5C is basically our third day. If you flip through section 1.5 in the textbook, there's just a ton of information about functions and how to analyze them. So we're finally to the part where we're going to talk about maximum and minimum values, and we're also going to look at the even odd functions again, where you guys took notes over the weekend. So you're writing down some information about relative maxima and minima. That's how you use the plural for maximum and minimum. And I would say all my honors pre-calculus students probably have no problem looking at a graph and saying, oh, that's a max, that's a min. Okay. Notice that in this picture, this looks sort of like a polynomial graph right now because it has several terms in it. There are 2 points that are identified as relative maxima, and there are 2 points that are identified as relative minima. So when we put the adjective relative in the front, it means relative to the graph around it. So if I just look at this, if I just look at this, relative maxima, I mean, obviously it's not the maximum for the function because there's another point that's higher than it, but relative to that graph around it, it is a maximum and it's where the graph is turning around. If we were going to actually identify the maximum for the function, that would be called a global maximum, meaning there's only one, it's for the whole function, it's the highest point. You know, pre-calculus is all about setting you up for success in calculus. So one of the things I've mentioned this previously that you'll be doing in calculus is finding critical points of a function. And the relative maxima and minima are critical points. You'll be able to, through calculus, find out where those points are and if they're maximum or minimums without ever having to graph the function. Right now, we're looking at it as a visual. Oh, here's a maximum, there's a minimum. Now, we're going to be doing this max and min on our calculators because a lot of times, you probably know from studying in Algebra 2, like with polynomials, you plotted your zeros, you did your end behavior, maybe you added the y-intercept, but you never really knew where your max and mins were. Okay, so now we're going to use that graphing calculator to find our max and mins. Now, remember, my suggestion to you at the beginning of school is to purchase the TI-83 or the TI-84 because those are the ones that I model in class. So if you have the Casio or a different version of the TI, I don't know where all the buttons are. I haven't memorized those calculators because I don't use them. So if that pertains to you, my one suggestion is if you can't find out how to get it to do the things we're doing, Google. Just type in like TI-83, how to find max and min. There will be a YouTube video. It is amazing the things that you can find for your calculators. So I just put that ownership on you. If you have purchased a calculator that I didn't recommend, you're just going to have to take accountability for that and figure it out. Okay. Some of you have used a graphing calculator before and some have not, so we're going to go kind of like step by step as if we've never used it before. Go ahead and turn on your calculator. Now, just to use it for a basic calculator function, everything is just normal down at the bottom, regular old calculator. If you're using it for graphing functions, there's 5 buttons right under the graphing screen. Those are basically where you find all your graphing stuff. Okay. So you want to hit the y equals button on the far left. I'm going to write some of this down on my sideboard. Write down this function. Okay, I'll go back to this slide if you want to jot down any notes after we practice on our calculator, but I'm going to pull up, oh, I got to open it. I'm going to pull up my graphing calculator on the screen. Okay, raise your hand if yours, when you bring this up, you don't have y equals, you have something else. R equals, it doesn't look like y equals. If it ever reads something different than y equals in that menu, that means you're in a different mode. Eventually in semester 2, we will put it in polar mode, but for right now, you pretty much should just be in the function mode where it's y equals. Okay, you can go ahead and in the y equals menu, you can type in this function that's on here. A couple of buttons that are going to be super helpful to you. Right next to your alpha button, which is one of the colored buttons at the top left. It's like the second button and then the alpha button. Right next to the alpha button, there's a button that says x, comma, t, comma, theta, comma, n. That's your variable button. So when you want to pull up this x, just hit x, comma, t, comma, theta, comma, n. Okay. If you're in a different mode, it will give you a different variable. So when you're in polar mode, it will give you theta because that's what we use. But we want it to be function mode, so we should be getting x's. And then the other one that you probably need to review is the caret function on the far right. That's your exponent. So like you want to do x comma t comma theta comma n. Then you want to do caret. And then you want to do 3. And then it should turn into x cubed. It should be up now. Help each other out.
How do you go back down?
The right arrow. Hang on one second. Yeah, so Abby's asking about this. When I do, let's see, x to the third, then I'm up in the exponent. So it's showing you a right arrow in that cursor, meaning hit the right arrow to go down. And then I can do plus 2x. You do have a squared button off on the side. Minus 3x minus 4. Okay, help each other get that typed in. Make sure your pod has it done.
Did you get this? Yeah.
Okay, let's see, recline me over. Help each other out. If you were borrowing mine, maybe it was already in there from the previous class. So double check you typed it correctly.
Okay, if I just need
Okay, now after you type in a function that you want to graph, listen carefully. Suppose you were using your graphing calculator before and you did like a lot of zooming in and out or something, or you moved your window so you weren't like centered. I'm going to show you my favorite zoom so you can kind of like put your graph right back at the center. Go ahead and in the middle of your graphing buttons, there's a zoom. Hit zoom. And you can kind of read through, there's like different ways to zoom. But if you want to recenter your graph, always do zoom 6. It's called standard. Okay, so you can either just type 6 or you can scroll down to the 6, and we should all get a picture that looks similar to this. What the zoom standard does is it gives us x from negative 10 to 10 and y from negative 10 to 10. So it just puts us right back at the center of the graph. Okay, everybody doing okay? Help each other out. Check your neighbors, make sure their graphs look all right. Yeah, there you go. Oh, you gotta shut that plot off, so hit enter on it. And then hit graph. Yeah. And you might have to do zoom 6. I don't know if yours have been around. Okay. So the next thing we want to do is, yes? Did you do zoom 6? Oh, your plot. That plot is highlighted. Okay. Now let's get into finding the min and max. So obviously we have some kind of polynomial up here. You can see there is some relative maxima and minima. Although I would argue we don't have a global max or min because our end behaviors are opposite directions. It's going to negative infinity and positive infinity. Okay. But hit second, and then above the trace button, it should say calc. So that's kind of like calculus or calculate. It does a lot of things that you would do. You can calculate the value of the function at a given x. We can use it to find zeros, which I'll ask you to do after we do max and min. But 3 and 4 are minimum and maximum. So I think there's a maximum first on the left. I'm going to choose 4. I'm going to find the maximum. Okay, so hit 4. Okay, now this is the weird part, and I need everybody's full attention, so I don't have to explain this 15 times. When you choose min or max, it's going to ask you a set of 3 questions. Left bound, right bound, guess. Okay. When it's asking about the left bound here at the bottom, it's saying, put your cursor on the left side of the maximum. So if I'm trying to find the max over here, I need to be to the left of it. So you got to move your cursor until you're on the left side. Now, the closer you are to the maximum, the more accurate the calculator's guess will be. So you don't want to go like all the way over to the left of your screen. Just get on the left side of the maximum. Once you're on the left side of the maximum, hit enter. Okay, sometimes it just puts a little arrow there. The new ones will put a line. Now it asks the second question, right bound. So now you need to move your cursor so you're on the other side of the maximum. Okay, so now I'm going to go to the right. Hit enter. And what the calculator is doing is it's creating this tiny little interval right here, and it's saying, do you want me to guess the maximum value in between these two x values? Which we do, right? The maximum is in between them. So it's asking me, do you want me to guess? I have to hit enter for yes. And then it tells me what my maximum is. So make sure on your calculators you can get a maximum of negative 1.87, 2.86. Oh, 2.06, thank you.
No, the first one was where it said.
2.06? Okay, now, if you get that maximum, go find your minimum. Okay? If you don't get that maximum, we got to figure it out. Your graph is not right. You forgot your plus. Anybody else not get that maximum? Let me know.
I got 2.07.
Yeah, that's probably close enough. Maybe your interval was wider so that it gets a little bit off. So that's fine. Okay, so get on the left side of the maximum. Sometimes it's hard to tell if you're on the max or over. So I just like, okay, now I'm on the left side, so I hit enter. Now I gotta get on the right side of that. So I'm pretty sure I don't guess. So you have to hit enter 3 times. The left side, the right side, See, I'll do my max real quick and we can compare to make sure we're doing okay. If you're not getting the same answers as me, check with your pod member or call me over. I got 0.54 and negative 4.88. Anybody having any issues out there? Okay. The last thing that I want to talk about before we set our calculators aside is if you go back to that second trace menu, in addition to min and max, there's also an option for zeros, which we covered last week, right? So last week we found zeros by factoring, algebra, but you can also find zeros of a graph if you have access to a graphing calculator by using this function. So I'm going to just find one of my zeros. How will I identify where the zero is on the graph? It's the x-intercepts. Okay. So I have 3 of them that I could find. I'm going to go ahead and find this one in between on the far right. So it's going to ask me the same 3 questions: left bound, right bound, guess. So I'm going to get closer to the 0, but stay on the left side of it where the graph is negative. Hit enter. I'm going to go on the right side of the 0 where the graph is positive. Hit enter. So I've crossed the axis. I know that the 0 is in between them. And then do you want me to guess where the 0 is? Yeah, it's at 1.560. Okay, so if you want to jot anything in your notebook about like second trace, left or right bounds, go ahead and do that now. You can also just think what's going to help you remember how to do that in your calculator. This is my big thing for you, when you're working on your homework tonight. You're going to be practicing with the graphing calculator. If you don't have a graphing calculator yet, you can always borrow one real quick at the beginning of class tomorrow and try typing those things in. But play around with it. It's just like when you get a new cell phone. It's a little bit weird at first, but as you use it more often, you kind of get to know what it can do. And I showed you min, max, and zeros. You can play around with other things in that menu, like finding the value of the function. If you graph 2 functions at one time, so use y sub 1 and y sub 2 in the y equals menu, you can find a point of intersection between the 2 functions. So kind of play around with that and just see what is available to your calculator. And here's information about zeros. So it's kind of the same set of direction. I found one of the zeros. It's go to that same menu, second trace, choose 0, choose left, choose right, choose guess. And you'd have to do that for each individual 0. Now, everybody who's purchased their graphing calculator, make note that you are able to use that on a ACT or SAT. So you might think about how could some of these features be helpful to you as you were taking a test. Could they speed something up for you? Okay, any questions before I leave the calculators for today? Okay. We're going to talk even odd. Now, this is the part of the section 1.5 where you took another set of notes. So hopefully, and for the most part, when I came around and I looked at people's stuff, even is symmetric with respect to the y-axis. What about odds? Symmetric to the origin. Excellent. So you probably have those 2 things written down. I don't think anyone in this room would have any difficulty with that visual for even odd. Is it symmetric to the y-axis? Is it symmetric to the origin? I'll show you a picture of an odd function here in just a minute. But what I want to focus on today in class is what I expect from you when you're asked to show that algebraically. So what if you don't have your graphing calculator? What if you don't want to make a graph of a polynomial? How can you tell if the function is even or odd, or neither, through an algebraic test? So on this image, I'm just going to pick 2 points. So I'm going to pick this point right here, 1, 1. And if it's symmetric to the y-axis, I can reflect it over the y-axis, and it would map onto this point, which looks to be negative 1, 1. So what's the only thing that changes in the coordinate? X. And what happens to x? It's the opposite. It changes signs. What happens to y? Stays the same. Okay. So remember, function notation, f of x is a fancy way to write y. So the algebraic test for even functions is right here. Does f of negative x equal f of x? If I put in negative x, will I get the same y as what I had in the original equation? So x and negative x give the same thing. They are equal. You guys told me that odd functions were symmetric to the origin. Some people might have been wondering, like, when they read that, like, how can you be symmetric to the origin? Because it's just a single point. If you think back to geometry, that's an example of, like, rotational symmetry. So, like, this image, if I rotate it 180 degrees, it maps onto itself. This side over here becomes this piece. Okay, so it has rotational symmetry. I'm going to pick another point on this one. I'll just pick this point right here. It looks to be like 1.2, negative 1. And then if I rotate on the other side, that would be at this point right here, which is negative 1.2, positive 1. So when you look at the points as you would go around, what changes in their ordered pairs? The y and the x. Now they're both opposites, right? X changes signs and y changes signs. So the algebraic test for that is going to look like, does f of negative x equal the opposite of f of x? Okay, side note, you should be done with your calculators at this point and focus on the algebraic test for even odd. You want to be on track. Okay, so this has 2 parts. If you change the x value, will you get the opposite y value? So not the same y value like it was for even, but the opposite y value. Let's do some practice with the algebra. On quizzes and tests, usually I have a lot of people who haven't practiced even odd, like by doing all of the work, because sometimes we tend to be lazy. And sometimes I'm okay with lazy, but if you're showing through algebra, whether this is even odd, it's kind of like a proof in geometry where you can't skip steps. You have to show everything. So even though you're like, oh, well, duh, it's even, you need to show the steps out here. So let's do f of x equals 2x cubed plus 3x. And we want to decide, is this even, odd, or neither? This is my expectations of what I want to see going forward on quizzes and tests. Okay, well, I know what f of x is. If I want to test for even, I need to know if f of negative x is equal to f of x. So I have to find f of negative x. This is just function notation. And it's saying, instead of putting in x, put in negative x. Substitute negative x for all the other x's. So over here, that's going to look like 2 times negative x cubed plus 3 times negative x. I'm making a substitution for x. It happens to be negative x. Okay, now it's a little bit hard to tell if that's the same thing as f of x as is because we haven't actually evaluated it. So you want to use what you know about exponents and sort of simplify a little bit. What happens if you take negative x times itself 3 times? Negative x times negative x times negative x. It comes out to be a negative, right? A negative times itself an odd number of times is going to be negative. So this is really 2 times negative x cubed, which we could write as negative 2x cubed. And then 3 times negative x is negative 3x. Okay, so I simplified it. Now, is f of negative x, negative 2x cubed minus 3x, the same as f of x? No, they are not the same. So f of negative x does not equal f of x, therefore it is not even. I have shown this is not an even function by algebra. If I don't put in negative x and get out the same y, then they're not the same thing. I want to check if it's odd. For an odd function, I want to test does f of negative x equal negative f of x. Now, the nice thing is if you've done even, you already have f of negative x. So now we just need to find negative f of x. When you're saying negative f of x, remember f of x is just a fancy way to write y. So it's just saying negative y. If your y is this whole thing, 2x cubed plus 3x, you want to make the whole thing negative. When you're thinking about the whole thing in math, you would use a set of parentheses, a grouping symbol. So I'm going to make the whole thing 2x cubed plus 3x opposite. I'll distribute that negative. I'll move this other screen so that we can see. I gotta move it up, sorry. You distribute that negative through the whole function. And what do you notice about negative f of x? Look familiar? It is, Celine says, f of negative x. So f of negative x equals negative f of x. They're both equal to negative 2x cubed minus 3x, right? So they're equal to each other. That means this one is odd. Now, if in the end f of negative x didn't equal negative f of x, then your answer would be neither algebraically. Okay, but this one must have rotational symmetry. If you wanted to type that one into your graphing calculator, you could type it into your graphing calculator, and you should see that it looks like if I rotate 180 degrees, it maps onto itself. Okay. Let's see. Will you try this one on your own with the algebraic check? While you're doing that, I'm going to pass out some of this stuff for your quiz. And then I'll go over this and then I'll talk about your quiz. So do a check for even, odd, or neither here. And I want the algebraic test, not the look at the picture test. You guys work on the one on the board for me, please. Okay, focus on the example on the board. I will talk about your quizzes momentarily. Let your quiz aside. Please focus on the example you're supposed to be working on. Even, odd, neither. I will talk about your quiz when I'm ready. Okay, if you want to check your test for even, your f of negative x to earn full points on a quiz or test, you should show me that you substituted negative x in for all your x's. You should show me that you evaluated that to be negative x cubed plus x squared plus 3. And then you should make some statement that says f of negative x is not equal to f of x, therefore it is not even. I want to see all of that. It's like a proof. You have to show all the steps. Now check for odd. Okay, for your odd test, I should see that you make the whole thing negative using your grouping symbols. You distribute your negative to all terms, so you get negative x cubed, sorry about that, negative x cubed minus x squared minus 3. And then when you compare that to your f of negative x, those things are also not the same thing. So this is not odd, therefore our answer would be if you take shortcuts and you don't show your work on these algebraic tests, you will not get your full credit. I want you to get your full credit, but you got to practice showing all these pieces. Are there any clarifications you'd like me to make on even, odd, or neither? I think on the homework, some of the questions ask you to like graph it in your graphing calculator and say even, odd, or neither by symmetry, but there's only like 3 of them, so honestly, you want to be practicing by algebraic test because that's more likely to show up on your quiz. Okay, so make sure that you practice the algebraic test. Your assignment is on the gold sheet, so it's another one from page 56. We have about 10 minutes before we're dismissed. I think 10 minutes. Is it third hour? 45?
40.
Oh, we get out at 40. Okay, we got 5 minutes. If you don't have a graphing calculator at home, right now would be a good time with those 5 minutes, maybe to do some min or max problems, if you can get a book real fast. Reminder that your 8 basic function sheet is due tomorrow. You should have that filled out. Domain, range, intercepts, parent graphs. Remember, I gave you the hint that inside your textbook could be very helpful. Okay. And then lastly, I want to talk about the quiz. Okay. Here's what you need to know for your quiz corrections. If you don't want to keep the grade that's at the top of your quiz, you need to complete quiz corrections on the yellow sheet that was passed out to the groups. So follow directions and do the yellow sheet. Put your problem that you missed in the corresponding box. So let's say you got number 1 right. You don't have to put anything in box 1. You missed something on number 2, go straight to number 2. So anything that has points taken off is something you would want to redo to get points back. Read in the top of the second column. It is not asking for a list of steps of how to do the problem correctly. It is asking you to describe your error. Okay. If you describe how to do the problem correctly, you are not answering what I want you to answer. Part of learning from your mistakes is making connections. And so if you have some kind of work down, you need to address what you were thinking that day you took that quiz and what doesn't match up to what in reality we should be doing. So what was your actual mistake? Identify that mistake, then you know to look for it in the future. If all you ever do is tell me the next steps to do it right, I don't think you really know what your mistake was, and you're liable to make it again. You don't know it was a mistake, and you can't identify it. So I want to be real clear. You should be describing your mistake. Be specific, be detailed. You're very smart. You're in here for a reason, so I want to see some smart statements. I don't know is not an appropriate answer for full credit. Some people maybe ran out of time, so if your problem is totally blank, obviously you don't have a mistake. So you could say you ran out of time. But if there's work there, if you put an answer, you put that answer for a reason. Okay? This is due on Wednesday. So you have today after school. You have tomorrow before school. You have tomorrow after school. You have 3 opportunities to come see me if you need help. You can email me. Wednesday morning, I'm not available until after TLT at 8:10. So if you wait until the last minute, that's on you. And I don't have time to sit down with you for 20 minutes before you turn it in. I would like everybody to get 10 out of 10. You can get all your points back. Your mistake. Redo the problem and show all your work. Yeah, you can put all the parts number 1 in the top. Okay, if you borrowed a calculator, make sure that you return it for me.
I have a